I'm Anil Kumar sharing with you application questions based on quadratic functions. We'll talk about revenue and demand functions in this particular video. The question here is, determine maximum revenue for the following demand functions of some items where X is the number of items sold in thousands. So X is the number of items sold in thousands. So whatever answer you get will be in thousands of dollars for revenue. Now what is revenue and how is it related with demand function? So let's look into this part first. So we know revenue is equal to number of items. There's a number of items times demand function. So that is a straightforward relation between revenue. That is the dollars generated when you sell an item. So demand, the cost basically at selling price, and the number of items sold for that price. So in short, that is what it is. Now let's first find the revenue function for both these. So we'll do them, both of them, one by one. So there are two examples. First one, demand function is given to us as minus 1.2x plus 4.8. To get the revenue function, R of x, we'll multiply the demand function by x, right? So we'll get p times p of x. So which is going to be equal to x times minus 1.2x plus 4.8, correct? Which I could write here. Let's open the bracket. We get minus 1.2x squared, and here we get plus 4.8x. To get the maximum revenue, we could do completing the squares, or we could do other methods like partial factoring. We'll do completing squares for the first one. So if I factor out 1.2 in the first case, I get here x squared minus 4.8 divided by 1.2 is 4. So we get 4x. Now, half of 4 is 2, right? So we'll do x squared minus 4x plus 2 squared minus 2 squared. So that is completing the squares. And as you know, that results into 1.2 times x minus 2 whole square, and square of 2 is 4. So that is what you get. Now we can open this bracket and get the equation, which is minus 1.2 x minus 2 whole square. And when you multiply, you get positive first and then 4.8, right? So 4 times 1.2 is 4.8. So from this equation, you know, it represents a parabola which opens downwards, kind of like this, where that is the vertex, and this vertex happens to be at 4.8. So the question here is, what is the determine the maximum revenue, right? So the maximum revenue will be in thousands of dollars. So the maximum revenue equals to, in dollars, 4.8 times 1,000 is okay. So $4,800. So that becomes the answer, right? So that is how you have to solve all these questions. Now you can always pause this video, answer the next one yourself. You can follow the same strategy. However, I'll kind of change my strategy a bit and use partial factoring this time. So revenue function, as we say, is x times the demand function p of x. So in this case, it would be x times minus 4x plus 12, which is equal to minus 4x squared and plus 12x. Now let me show you partial factoring methods. We'll do partial factoring. Well, in this case, since we do not have a constant term, you can say it is same as factoring. here, right? So we'll just factor and find the axis of symmetry to get the answer. So we get the revenue in this case as, if you factor, you could factor minus 4x in this case. So we get x minus 3. So that gives you two zeros, right? So in this case, if you try to sketch it, then the type of parabola which you're going to get is kind of like this, right? So it will goes down. However, what you understand from here, that you have a 0 here and the other 0 is at 3. So the center point here is midway between them, which is 1.5. So the revenue is maximum when x is equal to 1.5. You get the idea. So midway between the zeros. So let me write down this. 1.5 is 0 plus 3 divided by 2. It is equals to the axis, right, of symmetry. So we'll just plug in 1.5 here in the equation and find our answer. So minus 4 times 1.5, right, times, here we have 1.5 minus 3. That's it. So that gives you the revenue in thousands of dollars, correct? 1.5 is 3 over 2, 3 over 2. So anyway, so what you get here is you can use the 5, so minus 4 times 5 is 20, 0, 2, and you get 4 times 1 and 2. So you get 6, right? So you get 6 here with a negative sign, 6.0 has to be multiplied by minus 1.5. Now if you work in fractions, it is actually simpler. 1.5 is 3 over 2, right? 3 over 2. So you could do minus minus becomes positive, so it is 6 times. I prefer to write fractions here. See how easy it becomes. You can just cancel. This goes 3 times, and what we get is 9. Perfect. So 9 is the revenue. So the maximum revenue in this case is in thousands of dollars, $9,000. Does make sense to you, right? So getting back to this calculation, see how easy it is if I convert 1.5 to fractions. So I'll do it somewhere here again to show you this particular calculation, right? So which is minus 4, this is 3 over 2, right, times, and that is minus 3 over 2, correct? So if you have this, you know how easy it is. 2 and 2 cancel with 4 and you're left with plus 9. So at times it is simpler to use fractions than to work with decimal numbers. That's another take from this particular case, correct? So in this particular graph, this value will be 9. So I hope the learning which you take from here is to understand that revenue is number of items sold times the demand function. And you could apply partial factoring method or completing squares to find the maximum revenue as we did in this particular example. Feel free to write your comments and share your views. If you like and subscribe to my videos, that would be great. Thanks for watching and all the best.